Now the next important question that I am going to consider in this playlist is again from the mechanics section, and that is on page number 78. Earlier I have discussed question number 53. Now I am going to discuss this question number 54. Now this is question number 54. Now in this question what he is saying that we have a mass of 3 kg that is acted upon by 3 forces of 4 Newton, 6 Newton and 9 Newton and is in equilibrium. So he is saying that the object of mass 3 kg is acted upon by these 3 forces and it is in equilibrium. Now what do we mean by this term equilibrium? So by this term equilibrium we means that the sum of force is equal to 0. Means either the particle is at rest, or if it is moving with a constant velocity. So by this equilibrium we means that sum of forces equal to 0, or you can also say that this equilibrium is basically translational equilibrium. Now these forces are acting on this 3 kilogram block. This is that 3 kilogram block. Now how these forces are oriented, for that he is further asking that convince yourself that these forces can indeed be in equilibrium, and when the 9 Newton force is suddenly removed, determine the acceleration of this mass. Now the question here is that how the forces are applied such that this block is in equilibrium. Now from the knowledge of the vectors we know that this is 4 Newton force, 6 Newton force and 9 Newton force. So the resultant of any two forces, say I am considering this 4 and 6, so the maximum resultant of this 4 and 6 Newton is 10 Newton, and the minimum resultant for these two forces is 6 minus 4, that is 2 Newton. This resultant of 10 Newton will come when both the forces 4 Newton and 6 Newton both are acting in the same direction, and this resultant of 2 Newton will appear when 6 Newton and 4 Newton are in opposite direction. Now this 9 can be the resultant of these two forces of 6, say this is 6 Newton and say this is 4 Newton, because this 9 lies between 10 and 2. Means this is the maximum resultant that these two forces can produce, and this is the minimum resultant that these two forces can produce, and any other force that comes between 2 and 10. So the resultant force will always be between 2 to 10. Now the 9 Newton force comes between these two numbers 2 to 10 Newton. So we can arrange these two forces of 4 and 6 Newton such that these two forces combined will cancel out this 9 Newton force. So I am showing it here. Say suppose this is 4 Newton force, this is 6 Newton force, and say 9 Newton force is somewhere here. Now what is the angle between them? It is not concerned here, but we have to just look for that these two forces can balance this 9 Newton force. Other possibilities are also there. Say the force resultant of 9 and 6 Newton. 9 minus 6 is 3 and 9 plus 6 is 15 Newton, and 4 lies between this 3 and 15 Newton. So 9 and 6 can also be adjusted in such a way that 4 Newton can be resultant. Similarly 4 and 9 can also be adjusted. 9 minus 4 is 5 and 9 plus 4 is 13. So maximum resultant, minimum resultant, maximum resultant, minimum resultant, and here again 6 Newton lies between 5 and 13. But as per the question, he is saying that we have to remove this 9 Newton force. So we will consider this case in which 4 and 6 are balancing this 9 Newton force. So here 4 and 6 combined means the resultant of 4 and 6 is such that it is equal and opposite to 9 Newton force. Only under this situation, or only under such situation, the block of this mass 3 kg will be in equilibrium. So the first part, that in which he is saying that convince yourself that these forces can indeed be in equilibrium, so the forces must be applied in such a way. Now if we remove this 9 Newton force, so if I remove this 9 Newton force, so these two forces has a resultant of 9 Newton in this direction, and this 9 Newton was balancing this 9 Newton force. Now when I have removed this 9 Newton force, so the net resultant force on this 3 kg block is still 9 Newton in this direction. Earlier this 9 and this 9 was cancelling each other. Now only this 9 Newton is left, which is the resultant of 4 and 6. So he is asking that in such situation what is the acceleration. So in this situation the acceleration is the net force or the resultant force that is acting on this 3 kg mass is now 9 Newton, and divided by the mass of the object, that is 3 kg. So this gives us 3 meter per second square.